Good morning everyone. In this video we will discuss about the strength of data encryption standard. In the last video we had seen what is meant by data encryption standard. So it is a widely used symmetric key encryption process which has 64-bit input and the key size will be 56-bit and we are performing 16 round of operations. So the main strength of this data encryption standard depends on two main components which will be based on the key size and it is also based on the nature of algorithm. So in the DES in general we will be using 56-bit keys. So there will be a possibility of 2 power 56 keys we can generate. Which is approximately equal to, here I had given as 7.2 into 10 power 16. So when we use this 2 power 56, which is a very large number, the brute force attack is very difficult when we use DES encryption algorithm. So this is the main strength of data encryption standard. And next is nature of this algorithm. So actually it consists of 8 substitution boxes which we call it as S boxes, and also we are using initial permutation, expansion table and substitution tables for doing the single round of encryption process. For single round of 32-bit we are using all this substitution box, permutation box, all those things. So because of this feastal design structure criteria of these boxes, the indeed of this entire algorithm will not be considered as a public. So there can be a suspicion that the boxes were constructed in such a way that the cryptanalysis will be highly possible for an opponent who knows the weakness of the S box. If the cryptanalyst knows the weakness of S box, then only they can able to detect. But this is not an easy process. This is completely based on discrete logarithm process. So despite no one has so far succeeded the discrete logarithm and no one has proven this S box is weak. So next is timing attack. A timing attack is one in which information about the key or plain text is obtained by observing how long the message is transferred from a sender to receiver. So the timing attack exploits the fact that encryption or decryption algorithm often takes a slight variation in the amount of encryption process and decryption process that is purely based on the size of input. So and next we move on to differential cryptanalysis and linear cryptanalysis. So these are the two possible attacks that happens on the DES algorithm. So discrete cryptanalysis. So this is the general form of cryptanalysis which is applicable to the block cipher. So this differential cryptanalysis seeks to find the difference between the plain text which is encrypted. So this is mostly based on the chosen plain text attack. This means by using a plain text attack, anyone can able to find out the secret key. So the difference can be found using XOR operation. Difference is found between plain text and also to the cipher text. That difference we call it as differential equations. So statistical properties also depends on the S box and permutation box. So here the attackers try to find out the possible keys for rounds from R or from 16 rounds of DES and try to find out the key in any one of the round. So there are many types of differential cryptanalysis: high order differential cryptanalysis, truncated, impossible and boomerang attack. So boomerang attack means it takes only on the partial cipher text. That attack we call it as boomerang attack. And next is the linear cryptanalysis. So linear cryptanalysis, here the attackers will identify the difference between parity bits in the plain text, cipher text and also the key. So probably all the plain text, cipher text and the keys will have the parity bit for security purpose. So in the linear cryptanalysis, the attackers will try to find out the difference in the parity bits which are present on the plain text, cipher text and also on the key. So here the linear cryptanalysis, they identify the clues about the key for doing the linear cryptanalysis. So they decrypt each cipher text using all possible values in order to get the random result. So in linear cryptanalysis, the cryptanalyst will identify the linear relationship between the parity bits or between some bits, and they use some statistical process against one round for 2 inputs and 2 outputs. So the key obtained will be an intermediate, which we call it as candidate key. So by obtaining all those keys, they can able to identify the they do the cryptanalysis process in the DES algorithm. So I hope you understand what is the strength of DES and what are the two possible attacks on DES, that is differential cryptanalysis and linear cryptanalysis, and what is the difference between differential cryptanalysis and linear cryptanalysis. So thank you.